In this question we are told that f of x is equal to 1 by x square plus 1, g of x is equal to f of 2x minus 1 and h of x is equal to f of x plus 1. We are required to find out the sum of all the integer values of x for which at least two of the three functions intersect. So essentially we are asked to find out the cases where f of x is equal to g of x, which is essentially f of 2x minus 1, or we want f of 2x minus 1, which is g of x, to equal h of x, which is equal to f of x plus 1. Or finally we want to consider the cases where f of x is equal to h of x, which is f of x plus 1. So out of all of these three possibilities, what we are required to calculate is the integer values for which this is true and then calculate their sum. If you are looking at the third case, f of x has to equal f of x plus 1, or 1 by x square plus 1 has to equal 1 by x plus 1 whole square plus 1. Clearly we can take a reciprocal for both of them. So x square plus 1 has to equal x plus 1 whole square plus 1, and we can subtract 1 from both sides. So we want x square to equal x plus 1 whole square. If a square is equal to b square, then either a is equal to b or a is equal to minus b. If you are considering both those cases, either x has to equal x plus 1 or x has to equal minus x minus 1. The first case is clearly not possible, because if you cancel x from both sides, you are going to get 0 is equal to 1, which is not true. So that's a clear contradiction. In the second case, you would want 2x to equal minus 1, or x has to equal minus 1 by 2. We are only looking for integer values of x, so this entire case can be ignored. There is no integer value of x for which f of x is equal to f of x plus 1. If you are looking at the second case, you want f of 2x minus 1 to equal f of x plus 1. Like earlier, we'll just take the reciprocal and we'll cancel 1 from both sides. So essentially what you are looking for is 2x minus 1 whole square should equal x plus 1 whole square. If you are looking at this equation, like in the earlier equation, either 2x minus 1 has to equal x plus 1, or 2x minus 1 has to equal minus x minus 1. In the first case, this would imply that x has to equal 2. In the second case, it would imply that x has to equal 0, because 3x will equal 0. Both of them are integer solutions, so both of them are valid. In the first case, you want f of x to be equal to f of 2x minus 1. Again, we'll take the reciprocal like in the earlier case and subtract 1 from both sides. So you want x square to equal 2x minus 1 whole square. So again, either x is equal to 2x minus 1 or x is equal to 1 minus 2x. In the first case, it would imply that x is equal to 1, or in the second case, it would imply that x is equal to 1 by 3. We are only looking for integers, so this can be cancelled. So the three integers which satisfy the given condition are x is equal to 1, or x is equal to 2, or x is equal to 0, and their sum is equal to 3. So this will be the answer.